Hey everyone, before I explain anything, let me give a real-time question. Let's give to ChatGPT who wrote Harry Potter. The model instantly and confidently gave J.K. Rowling. What happening inside the model or LLM? How does it know that? What computations are running behind the scenes? There is a field called mechanistic interpretability, which having a several layers how this model or LLM works further. In coming next, I will explain each and everything in detail. Mechanistic interpretability. It is a subfield of AI and it analyzes the model internally. And these are the building blocks neurons and weights and layers. Coming to neurons, it is a tiny information that process the information. Coming to weights, numerical information, how that information was important held by the weights. Coming to layers, from token embeddings to MLP layer, it transform the input and it will get the intelligent output. Coming to visualization part of black box problem. See, if you hire any employee, when you give the input, he is giving the shockingly good output, but in a closed room. Right now, AI is the same. See, for example, you can see the right side a bunch of the neurons, which is forming a connections. This is what where mechanistic interpretability trying to do. Now coming to the concept of black box problem. See, GPT is a huge function like y is equal to f of x given theta, where x is input, nothing but your prompt. Theta is parameters, nothing but weights. Y is your output. See how you when you given the question, it is giving correct answers. What happening background we don't know. That is where mechanistic interpretability reverse this engine and model layer by layer and circuit by circuit. And finally, our goal is find the exact neurons responsible for the each specific behavior and how what is happening inside the LLM or model we get to know. Now I will tell something about what no researcher talks about it. That is called residual stream. It is a powerful architecture behind transformer. Why it was so powerful? Look at the visual. There is a growing pipe and it have the boxes from left and right, which is nothing but layers, MLP layers, attention layer 3, attention layer 2 and output layer. And actually all are think like a transformers works an assemble line. Like when you passes the input, it will go layer by layer and we will get output. Actually it will not work like that. It will work, for example, let's consider a doc like Google Doc, and in this doc there is a editable option for 12 people. And when we give the raw data input and person 1 is edited and it passes to person 2. A person 2 can see what is edited by person 1 and what is the raw data, and he will be edited and it passes to person 3, and person 3 can access that to see what is edited by person 2 and person 1, and it passes to next. This is how the transformers works. On left hand side you can see what you might think, like all are thinking like layer 1 information passes to layer 2, layer 2 information passes to layer 3 and to output layer. This is what model was wrong. Actually, coming to right side, this is what happening in real time. It is single shared stream. The main motto of this is the information not get lost or overwritten. It will be continued to the last layer, last output layer. And this is what happens. See, for example, in earlier slide I have given Google Docs example, right? Like for example, in a document, the colleague 1 has written something matter and colleague 2 added one table part and colleague 3 corrected it, and it reaches to final output layer, output transformer layer. It looks like a well defined document to the user or viewer. That contribution has been given by all the people, and he can the continue the information till last end. This is what actually happens, but all are think this is happening in real time. This is what happening, and this is what actual concept of residual stream. Here I will show you the thing where AI researcher talks about it, but no one goes inside it. That is attention heads. See, any AI model, when it reads any sentence like the cat sat on the mat, it will not rely on the single word. It will go to the multiple relationship between them, and it will give the understandable answer. See, let me give you an example. There is a four team members: head 1, head 2, head 3, head 4. When head 1 go to this sentence, he will understand in a different way where the action is doing on mat. Coming to the head 2, who is doing that action? Cat. And coming to the head 3, he will see the grammatical connection between the sat and cat. And head 4 will see in the different way compared to above patterns. So here you have to understand four persons are looking in the different patterns. Coming to AI terminology, all the patterns combined to one way, and it will give the understandable answer, where this all the attention heads will give understanding the different patterns, and it will be combined then, and it will give the one answer. This is known as attention heads concept. Earlier slide I have explained about attention heads with a visual effect. Now I will give the solid example and along with math intuition. See, in for example GPT-2 model, the what is happening inside. Every word is converted into three steps like query, key, and value. Query is nothing but a question or query. Key is nothing but a actual tag, how much it was important, and value is nothing but actual information. Actual information. Coming to now coming to the core math formula is nothing but attention is equal to softmax of q into k power t into v. Now actually what happened inside is it will consider each word with other, like sat with cat, sat with mat, and sat with the and some other. It will get high score. It will get mid range of score. It will ignore just low amount of score. So it will understand with the different patterns, and it will get to know which is matching which one. And finally, attention is telling that find the relevant words with assign the importance and combine the meaning. Combining the meaning. This is what actually happening inside the GPT-2 model or any LLM model. Before explaining the superposition concept, I want to ask a simple question. If you have a 768 numbers, in how many blocks do you store that? 768. It logically also correct, but that's not how neural networks work. Let's take a GPT model 2. Every word is converted into vector. So, for example, our main concept is compressing a more ideas in a fewer dimensions, ignoring a small overlap, because slight directions there is some overlap is there, but our neural network is fine to predict the next word, and it can handle that small noise, totally ignorable. So this is what the concept behind the superposition. See, if you see the left side, what we are thinking, here it will be there. See, for example, dimension what catness, dimension 2 franceness, and dimension 3 past tense. All maximum 768 features for 768 dimensions. Actually, this is not happening. In reality, language is huge. There has 1000 plus of features, and in the same of 768 dimensions only. So, what we will do is, with the slide dimensions, we will keep all our data, and in that fewer dimensions only. So it is the benefit that it has some noise in that and inference as well, but our neural networks is totally fine to handle that. This is what happening real time while coming to the superposition concept. Till now, we have learned so many topics like induction heads, Q, K, V, and superposition. Now we are telling that, for example, we are a human, right? So let us take a one pattern, simple pattern A, B, C, A, B. What coming next? C. Easily we can tell. But coming to GPT models, this is not like us. So, for example, A, B, C, A, B, what coming next? Big question mark. So here it will follow like pattern recognition. For example, earlier we have got any pattern like this. B. What came before? A. Same pattern is there. So after B, what is coming? Earlier we can see C is came. So obviously our model will tell next word is C. So it not at all guessing. It is repeating the pattern and like a algo. So we all researchers called it as induction circuit. Earlier slide we have seen the complete concept of induction circuit. Now I just want to pass one statement. Please listen carefully. A circuit is a small group of neurons, specifically attention heads and MLP layers, that work together to implement one specific computational behavior which is inside model. This is what happening in the circuit. So from earlier, all the slides I have explained in detail, from tokens to embeddings, from residual stream to attention heads, from superpositions to induction circuit. Now we are not just seeing the output anymore. We are all seeing the which is what architecture happening inside the model. Thank you guys. Thank you once again for seeing this video. Please share, subscribe.